Good morning. My name is Jayesh, Professor Jayesh Bisane from CSC Data Science from TGPCET, Nagpur. Today's topic clustering, and let's come to the topic clustering. What is clustering? Clustering is a process in which, wait a minute, what is clustering? Clustering is a process of group similar of objects. In this, in simple word, or we say that it is a clustering analysis. Clustering analysis is also known as a clustering. Similarly, similar data points form a cluster. In a cluster there are similar types of data points. This goes to ensure that data points within a cluster are more similar to each other than to those in other clusters. For an example, e-commerce website or retailers, they are finding the customer shopping habits, or they can analyze that. If any one group of the week, they are purchasing fitness, or other one are focuses on electronics, then it is help to companies to give a recommendation and improve customer experience. It is useful for them. Then there are these are the introduction of clustering. Now moving forward, clustering analysis. Input data. What are input data? Similar measures, cluster validations, application. In input data, there are feature vector, distance matrix, or a distance matrix is nothing but a similarity test, or a relation data is also same thing. Can be can be numeric or categorical or a mixed. Then next, similarity measures, or a cosine similarity, and one of them important cosine similarity or Pearson's correlation. Then we are forwarding to next point, clustering validation. Validation is a valuation using internal identity. It is a validations of particular data points or a data objects. Then next, applications, customer segmentation, documentation, and document clustering, anomaly detection, expression analysis. Then going to next point, there are the numbers of clustering methods or techniques. One of them partitioning, second one hierarchical, third one is density based, and fourth one is model based. Major clustering method, uh, one of k-means, or one of the partitioning example like k-means and k methods. This method divides in a dataset into k partition or a cluster, where each partition represents a cluster. In a cluster, there are the similar types of objects are present in a single cluster, and in a dataset there are number of clusters is also known as k means of that cluster. Let's move forward. What is exactly k-means cluster? Algorithm state choose randomly initialize k centroid, or assign each point to nearest centroid. It recompute centroid as mean of assigned point. Repeat step 3 to 4 until the coverage. Let me see. In first figure, we can mark up a centroid in a data. Then in a there are the there are the three centroid in, we can say also three clustered form in a data set, and around them there are the similar data objects surrounded by it. Next, hierarchical. In hierarchical, there are Dendrogram diagram is like a tree-like structure. Proceed to dendrogram, the tree-like of cluster. No need to specify K upfront. It is not necessary to specify anything in there. But the dendrogram are uh, desired level to get K cluster. Means k-means cluster assign each point of nearest cluster centroid and erective update centroid. And K medoids means partitioning around medoids. Similarly to K means but choose actual data point as centroid, making it robust or outliners. Next one, hierarchical method. These methods are created a tree-like structure. As we can discuss tree-like structure, then their types. One of them algorithmic, which is bottom to up, and divisive from top to down. In algorithmic method, which each data point starts as an individual cluster and merge step by step. Let's see them. A particular individual objects are present in that, and we form a cluster step by step. Yeah, and what criteria is linkage? Single linkage, complete linkage, average linkage, and word linkage. And what are the procedures? We can see that each dataset point its own cluster and own cluster. Each dataset have their own cluster. Compute pairwise distance between all cluster. We can distance means like distance between centroid and the uh, observing object. They find the distance between them, and decide to in which cluster that particular object joined us. Merge that two closest cluster into one. Repeat until a single cluster remains. This process have continuously repeatedly goes on until the single cluster node remains. Cut dendrogram to select final numbers of cluster. Next one is forwarding. Divisive clustering. Divisive clustering is top to down. It is easier to identify a single cluster. All points are in them. Then we can divide it as according to their distance, and we can also say that difference in them, and difference in them of an object which are present in that cluster. Now we are moving to algorithmic versus divisive, and difference between which are they as shown in PPT. Direction, start state, end state, complexity, typical use. In that, direction is a algorithmic uh, bottom to up, and where divisive top to down. Start states and cluster each point, one cluster all point means, and cluster each one. As well, we can say that each data point has their own cluster, and where the divisive in one cluster comes with all points. End state like one cluster and n cluster means in divisive we can form a n number of cluster, where in the algorithmic method we can form a single cluster from number of clusters. Complexity O n minus square log n. And divisive, there are more complexity as compared to algorithm method. Typical use, typical use, small to medium data set, large data.